Hello everyone, welcome to Math 115, College Algebra. This is lecture 20, and we're going to continue talking about trigonometric functions. And this section is on 7.3, where we're going to focus on the unit circle, and in particular, we're going to look at the sine and cosine. So basically, we're going to look at the sine and cosine of any angle. We're not going to restrict ourselves to the first quadrant. So it's not just a right triangle, it can be any angle. So let me start this by drawing a circle, and I'll just do this in more general to start, and then we'll specify a unit circle. So let me start with just a general circle that has some radius r. So let's say this is my radius r, and this location here is going to be x comma y, right, on the circle. So the definition of sine and cosine is that the sine of, this is angle theta right here, the sine of theta is equal to y over r, by definition, regardless of what quadrant I'm in. And then the cosine of the angle is equal to x over r. Again, by definition, it doesn't matter what quadrant that we're in. So like in this case, this would be like the x, right, that value, and this would be the y value, right, that length, the vertical length there. And in the first quadrant, they're both positive. But if I were, say, in the second quadrant, right, let's say I'm in this quadrant now. So like this would be my x, which is negative, right? And the y is positive. The r, by the way, is always positive, right? Because the r is a distance from the origin out to the circle. So the r is always positive. But the x and y are positive or negative depending on which quadrant they're in. So again, in this case, in the second quadrant, the x is negative, the y is positive. Okay, and I'll talk more about that in a little bit. Now, what is a unit circle? A unit circle is sort of just a special circle where the r, the radius, is equal to 1. So in this case, we had a general r, but with a unit circle, the radius r is equal to 1. Okay, so it's like a special case. So here, let me draw this again. So here's this is now my unit circle. Right, so now this distance is just 1. So this is x, this is y. So that means that the sine of theta, remember in general it's y over r, but in this case, since r is 1, it's y over 1, which is just y. And in cosine of theta is x over r, but in this case, with the unit circle, r is just 1, so this is going to be x over 1, which is just x. So we've really simplified things, right? We can say that sine of theta is equal to y, and cosine of theta is equal to x, if you have a unit circle like this. Okay, so let's first look at some special angles. Let's say we have a 90-degree angle. So that would be like this, right? So this is the point. This is 90 degrees. And obviously, remember the radius is 1 here, right? So that point is going to be 0, 1, right? And the x is 0, the y is 1. So that means the sine of 90, which is equal to the y, is equal to 1, right? And then cosine of 90 is equal to x, so that's equal to 0. Then let's do 180. So I'm just doing special angles where the point lies right on one of the axes. So this is 180 degrees, right? So the coordinates at that point are -1, 0. Right? So x is -1, y is 0. So that means the sine of 180 is going to be y, so that's 0. And the cosine of 180 is going to be equal to x, but that's -1 in this case. And then the two other special angles are 270 and then 360. Okay, so now 270 would be like this, right? So it'd be from here all the way to here. So the coordinates of that point are 0, -1. So that means sine of 270 is going to be y, which is -1, and cosine of 270 is going to be equal to x, which is 0. And then finally, 360. So here's my circle. 360 is all the way around once, right? So this is 360 degrees. So this point right here has the coordinates 1, 0. So that means sine of 360 is equal to 0, right? That's y. And cosine of 360 is equal to 1. Notice that this angle right here could also be 0 degrees, right? If I start there and the terminal side is at the exact same place, then this also represents 0 degrees. I'll say, so we also know that if I look at the sine of 0 degrees, that's going to be 0, and the cosine of 0 degrees is also 1, right? Because 0 and 360 are coterminal. Okay, now in terms of the signs, S-I-G-N, right, of the sine and cosine for each quadrant, well, that just depends on the sign of the x and y values. So if we look at this, so I have my unit circle. This is quadrant 1, where we know in quadrant 1 the x value is positive and the y value is positive, right? Anywhere in quadrant 1. So therefore, the sine of theta, which is equal to the y value, that's going to be positive, right? So I'll say that's greater than 0. And the cosine of theta is also positive, right? Greater than 0. In quadrant 2, we know that the x value is negative, but the y value is positive. So that means the sine of theta, which is equal to y, remember this is just a unit circle, right? This is r equals 1, so it's a unit circle. So the sine is equal to y, so that's going to be positive. I'll just write it as greater than 0. And the cosine, which is equal to x, is going to be negative, so that's less than 0. In quadrant 3, both the x and y components are negative, right? Negative, negative. So that means both sine and cosine of the angle are going to be negative. So they're going to be less than 0. And in quadrant 4, the x is positive, but the y is negative. So that means the sine, since it's equal, sine of theta is equal to y, right? That'll be less than 0. This is less than 0. And then the cosine, which is equal to x, will be greater than 0. Okay? Now, later, we will also mention the other 4 trigonometric functions, right? So tangent, cosecant, secant, and cotangent. So the way to remember this, there's sort of a mnemonic that we can use. We could say that in the first quadrant, it turns out all of the trig functions are positive. So all are positive in the first quadrant. In the second quadrant, the sine is positive. And actually the cosecant, but we'll talk about that later. So the sine is positive in the second quadrant. So I'll put sine. In the third quadrant, it turns out, we haven't talked about tangent yet, but the tangent is positive. In the fourth quadrant, the cosine is positive. Okay, so the ones I'm underlining, these are the trig functions that are positive. In the first quadrant, all of them are. In the second, the sine is. In the third, the tangent is. In the fourth, the cosine is. So one like mnemonic that sometimes people use is all students take calculus, right? At least that's the one I've heard. So all students take calculus. It's just a mnemonic to help you remember. In the first quadrant, all the trig functions are positive. In the second quadrant, the sine is positive. In the third, the tangent is positive. Actually, that's why we said that sine and cosine were negative, right? So tangent is positive. In the fourth quadrant, the cosine is positive. Okay, and again, we haven't talked about tangent yet, but the other ones we have. So all students take calculus. I think that's worth remembering. All right, now we could also derive an identity here using the unit circle. So I'll just draw part of this out. So this is like part of my unit circle. And notice here that if this radius is equal to 1, I can draw out a right triangle, right? Remember, this is like my x value. This is my y value because this coordinate would be x comma y. So I basically have a right triangle here, right? I have a right triangle where the two legs, their lengths are x and y, and the hypotenuse, which is the radius, has length 1. Right? And this is the angle theta here. So what I can do is I can use the Pythagorean theorem. Oops, let me spell it correctly. Then we can show that, well, it's a right triangle, right? So I know that x squared plus y squared has to equal the hypotenuse squared, which is 1 squared. But because it's a unit circle, we know that x is the same as cosine theta, right? And y is the same as sine theta. So if I plug those in, I have cosine. Usually the way we write this is squared theta. That means, so this means, I'll write it over here so it's out of the way. This means this. It means cosine of theta, the whole thing squared. Just kind of a shorthand notation way of writing that. Okay, so cosine squared of theta plus, if I take y, plug it in and square, I'm going to get sine squared of theta equals 1 squared, but that's just 1. So this is very important. This is called the Pythagorean identity. Okay, and it comes from the Pythagorean theorem. The Pythagorean identity. Identity basically means it's equal to 1. All right, so what I want to do next is use that to solve a couple of problems. Okay, so here's one example. Let's say you're told the point P is on the unit circle. if the y-coordinate of P is 3/6 and P is in the second quadrant, find x. Okay, so it might help to draw a picture here, right? So again, let me read the problem. The point P is on the unit circle. If the y-coordinate of P is 3/6 and P is in the second quadrant, we want to find x. Okay, so here's my unit circle. I know that I'm in the second quadrant, so something like this. And I'm given the y value, right? We're told y is equal to 3/6, but we can simplify that. We should write it as 1/2, okay? And that coordinate there is going to be x, comma, y, so x, comma, 1/2. So this is the angle, theta. So given that information, I want to figure out x, what x is, right? I want to find x. Well, what we could do is we could use Pythagorean theorem, right? So we know that in this case, here, I'll extract out this right triangle here. So this is y, that's known, that's 1/2, and then this is going to be x, right? So I know that, and since it's a unit circle, this radius is 1. So like this is my right triangle. So this is 1, this is 1/2, this is x. So I know that x squared, right, plus 1/2 squared, just using Pythagorean theorem, equals 1 squared. So this is x squared plus 1/4 is equal to 1. And then if I subtract 1/4 on both sides, right, I have x squared is equal to 1 minus 1/4. Well, that's the same thing as 4/4, right, minus 1/4, which is 3/4. So this is equal to 3/4. And then finally, I can take the square root of both sides. Let me finish it up over here. So x squared is equal to 3/4. So now I take the square root. But remember, when you take the square root of both sides, it's going to be positive or negative, right? So x is equal to plus or minus the square root of 3 over the square root of 4. But what's the square root of 4? That's 2. Right? I can break this up. This is plus or minus the square root of 3 over the square root of 4. But the square root of 4 is just 2. So it's going to be plus or minus the square root of 3 over 2. However, we know that we're in the second quadrant. So because we're in the second quadrant, the x has to be negative, right? So we know that the correct answer in this case is x is equal to negative square root of 3 over 2. So that would be the answer. Okay, this now, by the way, this also tells us, remember with the unit circle, sine of theta is equal to y and cosine of theta is equal to x. So we just found that, well, we were given sine of theta is equal to 1/2 and cosine of theta is equal to negative radical 3 over 2. Okay, so in essence, we knew the two trig functions as well of that particular angle theta, which is measured from the positive x all the way to that terminal side. Okay, here's another question. Let's say you're told this. If cosine of the angle theta is equal to negative 2/9, and theta is in the third quadrant. Find sine of theta. So again, we could use the Pythagorean identity, right? Because we know that cosine squared of theta plus sine squared of theta is equal to 1. Cosine is negative 2/9, so this is negative 2/9 squared plus, we don't know sine yet, so I'll just leave it as sine squared. That's got to equal 1. So then if I square negative 2/9, well, negative 2/9 times negative 2/9 is 4 over 81. I need to subtract 481 from both sides. 481s. So if you do 1 minus 481s, we need to have the same denominator, so I can rewrite this. If I multiply by 81 over 81, I can write this as 81 over 81 minus 4 over 81. That's what? 77 over 81. So I have sine squared of theta is equal to 77 over 81. Now, how do I get sine of theta? I need to take the square root, right? So now we take the square root of both sides. It can be positive or negative. We'll have to figure that out later based on what quadrant we're in. So this is going to give us sine of theta, right? If I take the square root of sine squared, I just get sine of theta back out. And this is going to be either positive or negative square root of 77 over square root of 81, but square root of 81 is 9. So then the question is it positive or negative? Well, because I'm in the third quadrant, right? Remember it says, and the angle's in the third quadrant. So it's something like this. So something like that, right? We're in the third quadrant. Then that means both the sine and cosine are negative. Okay? How do we know that? Well, because both the x and y are negative, right? Remember, y is equal to sine and x is equal to cosine if you have a unit circle. Or you could think of it as all students take, so tangent's positive, which means the others, sine and cosine, are negative, calculus. Okay, either way, you could also look at the x and y values. These are both negative, so that means sine has to be negative. So the correct answer is going to be sine of theta is equal to negative square root of 77 over 9. That would be the solution. Okay, what about, so often you'll see these diagrams where they want you to know sine and cosines of like some basic angles, right? Or think of them as like special angles. So let's talk a little bit about that. Okay, so finding sines and cosines of special angles. All right, so the way that I usually present this is I talk about two special triangles. One of them is a 45, 45, 90 right triangle, and the other is a 30, 60, 90 right triangle. So let's start with that. So I'll start with the 45, 45, 90 right triangle. Okay, so this is a 45, 45, 90 right triangle. In other words, this is 90-degree angle, and these two angles are 45. So notice that it's an isosceles, right, triangle. So it's 45, 45, 90. right triangle. So since those two angles are equal, that means these two sides are equal. Let's just call the hypotenuse, let's call it length 1, and these are x and x. So from the Pythagorean theorem, we know that x squared plus x squared is equal to 1 squared, right? Or I could say 2x squared is equal to 1, which means x squared, but divide by 2, x squared is equal to a half. And if I take the square root of both sides, again, it should be positive or negative, but in this case, we're going to assume it's positive, right? Because it's a length of a triangle, so it has to be positive. So x is going to be the square root of 1/2. But we can rewrite this, right? I could write it as the square root of 1 over the square root of 2. Right, that's one rule, but that square root of 1 obviously is just 1. And then we could rationalize the denominator. Remember that how to do that? To get rid of the radical out of the denominator, I would multiply both numerator and denominator by radical 2. So this would be radical 2 over, and then radical 2 times radical 2 is radical 4, which is 2. So we know that the x is equal to radical 2 over 2. Okay, so now let me draw this again. So this is 1, this is radical 2 over 2, this is radical 2 over 2. Okay, so that tells us, or this is 45 degrees. That tells us that the sine of 45 degrees, remember sine, we can think of this several different ways, right? Since I have a right triangle here, let me just think of sine as being opposite over hypotenuse, right? So opposite is going to be radical 2 over 2 over hypotenuse, which is 1. So this is simply radical 2 over 2. And then the cosine, if we use our right triangle trigonometry, it's adjacent over hypotenuse. So relative to, say, this angle here, this 45, this is the adjacent side, right? And this is the hypotenuse. So again, it's going to be radical 2 over 2 all over 1, but that's radical 2 over 2. So that's one of the special angles, right? It's 45 degrees. And we found that the sine of 45 is radical 2 over 2, and cosine of 45 is radical 2 over 2. Okay, so that's the first special angle, 45 degrees. Okay, by the way, sometimes you'll see this done like this. Like they will call the triangle, so it's a 45, 45, 90 right triangle. Sometimes what they'll do is instead of calling the hypotenuse equal to 1, they'll call each leg equal to 1, and that makes the hypotenuse radical 2. Right? So if this is 45 degrees, then you can use the same argument as before. Sine of 45 is going to be opposite over hypotenuse, and then cosine of 45 is adjacent 1 over hypotenuse, radical 2. And then if we rationalize the denominator by multiplying by radical 2 over radical 2, these are both going to be radical 2 over 2. Okay, so either way, if you want to memorize this particular triangle, 1, 1, radical 2, or you could memorize this one, where the hypotenuse is 1 and the sides are radical 2 over 2. Either way, you get the same result. This is the important result that I boxed in blue here. Sine of 45 and cosine of 45 are both radical 2 over 2. All right, the other special triangle we want to use is ultimately going to be a 30, 60, 90 right triangle. So to get that, I'm going to start with this picture. I'm going to start with an equilateral triangle. That means all sides are equal. Not drawn very well, but all sides are equal. And that means that all these angles are going to be 60 degrees. And since all the sides are equal, let's give them a value. The convenient value to call them is 2, length 2. And then what I'm going to do is I'm going to bisect this angle in this bottom side. So I have a right triangle here. And notice that if I bisect that, then this length is simply going to be 1, right, because it splits it in half. And this angle from here to here is going to be 30 degrees. So if I just look at this right triangle, I'll extract it out. I'll draw it in red here. So if I look at that, this is 1, right? This was 60 degrees. This was 30 degrees. This was 2. And then I can find this side, let me call it y for now. I can find it using Pythagorean theorem, right? I know that 1 squared plus y squared has to equal 2 squared. So this is 1 plus y squared is equal to 4. If I subtract 1, I have y squared is equal to 3. And then finally, if I take the square root, and normally it's plus or minus, but in this case it's a length, so it has to be plus. So y is equal to the square root of 3. So this side is really equal to the square root of 3. So usually when you draw a 30, 60, 90 right triangle, right, so this is like a 30, 60, 90 right triangle. Usually you name the lengths. The shortest leg is 1, the hypotenuse is 2, and the long length is radical 3. But any multiple, right, if you can multiply those by any number, and that will also be true, right, because they're in proportion. But usually you just call it 1, 2, radical 3. Okay, so now using right triangle trigonometry, let's find the sine of 60 degrees, cosine of 60 degrees, and then we'll find the sine of 30 degrees and a cosine of 30 degrees. So sine of 60. So here's my angle, 60, right? Sine is opposite, which is radical 3, over hypotenuse. So this is going to be equal to radical 3 over 2. Cosine of 60 is going to be adjacent, which is the 1 over hypotenuse. So cosine of 60 is 1/2. Now what about 30 degrees? So now I have to look at this angle. So sine of 30. Well, sine of 30 is going to be opposite, which is the 1 over hypotenuse. So this is 1/2. And then cosine of 30 is going to be adjacent, so radical 3 divided by 2. Okay, so those are the other really important special angles you should know. The sine and cosine of 60 and 30 degrees. So again, I'll box them in here. So to summarize this, so actually this diagram summarizes this nicely. And actually it does the special angles for each of the quadrants as well. So if you look here, right, remember that cosine, this is a unit circle, first of all, right? So r is equal to 1. So cosine of theta is simply equal to x, and sine theta is equal to y. So if you look like at 30 degrees, right, it also gives you the angle in radians. Do you remember 30 degrees is pi over 6 radians? We could convert back and forth. We did that in section 7.1, right? So you should kind of be familiar with both degrees and radians. Often we use degrees a little bit more often, but you should be familiar with both sets of angles. So cosine of 30 is equal to x, but we can see the x value here is radical 3 over 2. And then sine of 30 is equal to y, but in this case y is 1/2. Okay, and then cosine of 45 is radical 2 over 2. Sine of 45 is radical 2 over 2. Cosine of 60 is 1/2. Cosine of sine of 60 is radical of 3 over 2. So you should definitely be familiar with what's going on in the first quadrant. And actually, even the 0 degrees and 90 degrees, which we talked about earlier as well, right? Remember, cosine of 0 degrees is equal to 1, and sine of 0 is equal to 0. And then cosine of 90 is 0, sine of 90 is equal to 1. So you should know those angles. That's important for the first quadrant. And notice if you go to any of the other quadrants, right? So let's say 120 degrees. Notice that the values, at least the absolute value of the sine and cosine, are the same as sine and cosine of 60 degrees. So if you look at sine and cosine of 60 degrees, right? Cosine is 1/2, sine is radical 3 over 2. If you look at cosine and sine of 120 degrees, cosine is negative 1/2, sine is radical 3 over 2. So these match. The only thing that's different are the signs, and that's because you're in a different quadrant, right? In this case, the cosine, which is x, is positive 1/2. In this case, the cosine of 120 is negative 1/2 because the x is negative. But the sine of 120 is the same as the sine of 60. Okay, so I will show you how to find these more carefully a little bit later using something called a reference angle. All right, so I'll explain that a little bit more later. So really all you have to know is the special angles in the first quadrant, and then ultimately we can find them for any of these quadrants because they're the same values, but the signs, S-I-G-N, might be different. That's the only thing that changes. Okay. Actually, let's do that now. Let's talk about reference angles. So using reference angles, to find cosine and sine. So, and here's the important thing. Angles have cosines and sines with the same absolute value as their reference angles. So angles have cosines and sines with the same absolute value as their reference angles. The sign, S-I-G-N, right, either positive or negative, can be determined by the quadrant of the angle. So by the quadrant of the angle. So if you know those special angles for the first quadrant, we can, for any quadrant, we can find the special angles using the reference angle, and then we can figure out the correct SIGN, whether it's positive or negative, just based on what quadrant we're in. Okay? So let me do an example. First of all, let me just review. Do you guys remember what reference angles were? We went over that in 7.1 as well. Remember, that's the angle with respect to the x-axis or negative x-axis, right? Regardless of what quadrant you're in, you always measure it with respect to the x-axis or negative x-axis. So let's say you're asked for the reference angle of 213 degrees is what? So here I would draw a picture, right? Let's say We know halfway around is 180, right? So 213 is going to be somewhere in here maybe. So this is 213. So the reference angle is just the angle with that terminal side, what it makes with, in this case, a negative x-axis. So this would be the reference angle theta right here. So how do I find theta? Well, I know halfway around is 180, so theta must be equal to 213 minus 180. So in this case, it's going to be 33 degrees. So this answer would be 33 degrees. Okay. Same thing. Let's say you're in radians, right? So let's do one more example of that. What is the reference angle of 13 fifths pi radians? So again, draw a picture. Okay, this you have to think about a little bit, right? We know that 2 pi radians is 1 revolution, right? So 2 pi radians is 1 revolution. And then how much further do I have to go? Well, one way of doing this is I can subtract, right? So I have 13 fifths pi minus 2 pi. Well, 2 pi I could write as 10 fifths. Right? I need to have the same denominator. So I multiply basically by 5 over 5. So this is 10 fifths pi. And that's going to equal 3 fifths pi radians. Okay, so that means the original angle is going to be something like this. I guess it'll be in the second quadrant, right? So it goes all the way around once and then goes another 3 fifths pi. So the reference angle is this angle right here. So how do we find that? Well, we know that this angle, I'll do it in red, I went around once plus, and this angle must be 3 fifths pi radians. So to find the reference angle, the theta, well, it's got to be 180 degrees, which is pi radians, right, minus 3 fifths pi radians. Well, I can subtract these if I have the same denominator, right? So pi I can write as 5 fifths pi, or 5 pi over 5, minus 3 fifths pi. That's got to be 2 fifths, right? Pi radians. So that would be the reference angle in this case, 2 fifths pi radians. So that would be this answer. Okay, so we have to know how to find the reference angle first. And then once we have the reference angle, that's going to help us compute the sine and cosine of any angle. Right, so here's an example. Let's say I have, and you guys can like double check this on that diagram I gave you, right? Think of it as like a trig wheel, that trig wheel, which gives all those special angles for the entire rotation for each of the 4 quadrants. Right, but let's see if we can come up with the correct answer by using reference angles. So let's say I want to compute sine of 225 degrees and cosine of 225 degrees. Okay, so first I have to figure out the reference angle. So first of all, where's 225? Let's kind of draw a picture, right? We know that we're in degrees, so halfway around is 180, and then I need to go another 45. So I guess it's going to be like this, right? So this would be 225 degrees. So the reference angle here is going to be 45 degrees. So I know that these answers are going to be the same as the sine of 45 degrees and the cosine of 45 degrees. The only thing that's going to be different is the SIGN, right? Because that depends on what quadrant you're in. So sine of 45, cosine of 45, those you should know, right? Those you should know pretty much cold. Remember, sine and cosine of 45 are both radical 2 over 2. So that means sine of 245 and cosine of 245 are also going to be radical 2 over 2, except we have to consider the SIGN out front. So if we're in the third quadrant, so here's first, second, we're in the third quadrant. Remember, in the third quadrant, right, you can think of this as all students take calculus. Tangent is positive, but sine and cosine are negative. Right? If tangent's positive, that means the other two are negative. So sine and cosine are negative. The other way to remember it was the x and y are both negative. And for a unit circle, cosine was just x, sine was just y. So they're both negative. So these had to both be negative. Okay, so that would be the answer. So we got the correct absolute value, radical 2 over 2, just by looking at the reference angle. Right, because we know that. We can think of it as being in the first quadrant now. Just look at the reference angle. But then to get the correct sign, we have to look at what quadrant we're in. Since we're in the third quadrant, both sine and cosine are negative. Okay, here's another question. So let's say you're asked this. If theta equals 2/3 pi, then what is cosine of theta and what is sine of theta? Okay, so let's figure out what quadrant we're in first of all. Well, 2/3 pi. So pi, right, 1 pi is 180 degrees. 2/3 pi is going to be like in the second quadrant, like this. Which means the reference angle here is going to be pi minus 2/3 pi. Okay, so you can think of this as 3/3 pi minus 2/3 pi, which is 1/3 pi. So this is pi over 3. All right, so the reference angle is pi over 3. So we know, right, we know that sine of 2/3 pi and cosine of 2/3 pi. That's what we want to find ultimately. And we know that their values are going to be equal, at least an absolute value, to the sine of pi over 3 and cosine of pi over 3. Right, because in terms of absolute value, the sine and cosine of the actual angle is equal to the sine and cosine of the reference angle. The only thing that's different is the SIGN, right? Whether it's positive or negative. And we figure that out later based on the fact that we're in the second quadrant, right? We're in quadrant 2. Okay, so what is sine of pi over 3, cosine of pi over 3? Well, here you have to remember, if you want, you can do the conversion, right? For me, it's easier to think in degrees because I'm so used to degrees. So we can just convert this to degrees, right? We know that there is 180 degrees for pi radians. So if I multiply by that unit conversion factor, 180 over pi, the pi's are going to cancel. 3 goes into 180 60 times. So this is the same as 60 degrees. So this is really the same as sine of 60 degrees and cosine of 60. Okay, so these are ones that you should know pretty much cold. If not, you could draw a quick picture, right? You could draw the 30, 60, 90 right triangle. So here's what I do if I forget. This is 60, this is 30. Remember, the short side is length 1, the hypotenuse is 2, and the long leg is radical 3. So sine of 60 is opposite over hypotenuse. So this would be radical 3 over 2. And the cosine of 60 is adjacent over hypotenuse. So this is the 1 is adjacent to the 60 divided by 2. Okay, so sine of pi over 3 or equals sine of 60, which is radical 3 over 2. Cosine of pi over 3 is equal to cosine of 60, which is 1/2. So that means sine and cosine of 2 pi over 3 is also going to be radical 3 over 2 and 1/2. The only thing we have to be careful with is we want the correct SIGN out front. Well, because we're in the second quadrant, remember we have all students take calculus. So the sine is positive, right? So this is positive and the cosine is negative. Again, the other way you can think about that is the x and y components. So if it's a unit circle, cosine equals x, sine equals y. The x is negative in that second quadrant, the y is positive. So the sine is positive, the cosine is negative. Okay, let's do another one here. So let's say if theta equals negative 5 pi over 4, find sine of theta and cosine theta. All right, so we want sine of negative 5 pi over 4 and cosine of negative 5 pi over 4. All right, so first of all, let's get an idea of what quadrant this is in, and we need to figure out that reference angle because that's going to help us. So remember, when you measure an angle and it's negative, then you start from the positive x-axis and you measure clockwise, right? So 5 pi over 4 is basically, it's basically 4 pi over 4, right, which is pi plus 1/4 pi. So I'm going around halfway, that's pi, and then 1/4 of pi, which means I'm going to be in the second quadrant like this. So this would be negative 5 pi over 4 radians. And based on that, by reasoning through that, that means that our reference angle here is just pi over 4. Okay, so these answers are going to be the same as sine of the reference angle, pi over 4, and cosine of pi over 4. However, remember pi over 4 radians, because I like to think in degrees, so I'll write this as 180 over pi. Let's convert this. So again, pi's cancel. 4 goes into 4 once. 4 goes into 180 45 times. So this is 45 degrees. That's something you should know. So pi over 6 is 30 degrees. Pi over 4 is 45 degrees. And pi over 3 is 60 degrees. Those are ones that come up a lot, so you should probably know those. So this is the same as sine of 45 degrees and cosine of 45 degrees. And remember, these are both going to be radical 2 over 2. If you forget that, right, you can think of that special right triangle. So this is 45 degrees. This is 45 degrees. And then if I call this 1, 1, this is radical 2. So that means cosine of 45 is adjacent over hypotenuse. And then sine of 45 is the same thing, right? Opposite, which is also 1 over hypotenuse. But then you can multiply these by radical 2 over radical 2 to rationalize the denominator. So you have radical 2 over 2. Same thing here. Okay, but again, those are important. You should probably just memorize those. There's a few you should just know cold. So these are going to be the same answers, right? Because remember, any angle has the same value as its reference angle. The only difference is the SIGN. So sine of negative 5/4 pi has got to be the same as sine of pi over 4, except it might have a different SIGN out front. We'll think about that in a second. Same thing with cosine of negative 5/4 pi. Has to have the same absolute value as cosine of pi over 4. But since we're in the second quadrant, remember what's positive? The sine is positive, so this is positive. The cosine is negative. Okay, so that would be the answer. So sine of negative 5/4 pi is radical 2 over 2. Cosine of negative 5/4 pi is negative. Yeah, I said that backwards, right? Sine of negative 5/4 pi is positive radical 2 over 2. Cosine of negative 5/4 pi is negative radical 2 over 2. Because we're in that second quadrant. Sine is positive, cosine is negative. Okay. What about this? Okay. Let's say we want to find, let me do this in back here. Find an angle and I want that angle to be between 0 degrees, so greater than 0, less than 360, that has the same sine as 60 degrees and the same cosine as 60 degrees. Okay, so again, I would draw a picture, right? So $60 degrees is like this, right? So I want to find an angle where the sine of that angle is the same as the sine of 60 degrees, right? So the sine of 60 degrees, I want it to be equal to the sine of this new angle. And then same thing with the cosine. Cosine of 60 degrees, I want it to be equal to the cosine of this new angle. So I want to find these two angles here. Well, remember, the sine of 60, right, is going to be equal to radical 3 over 2. So in this case, right, we know that the sine of 60 is positive radical 3 over 2. So where else do I have a positive? Where else, like what other quadrant is sine positive in? And for what angle is it equal to radical 3 over 2? Well, we know it's positive in the second quadrant. Remember, it's all students take calculus, right? So it's positive in the second quadrant. So that means that if the reference angle in the second quadrant is 60 degrees, then it's going to have exactly the same values, and the sine is also positive there, so it has to have exactly the same value. So, but what is that angle if we measure from the positive x-axis? That angle is 120 degrees. So it looks like sine of 60 is the same as sine of 120. Right? And notice it makes sense because their y values are both positive, right? Okay, what about cosine of 60? Well, cosine is positive in the fourth quadrant. So cosine of 60 is going to equal to the same as, if this reference angle is 60, right? The x values will be the same here. So what actual angle is that? Well, I need to measure. I'll do it in a different color. I need to go all around to here. So that angle. Well, what is that? It's going to be 360 degrees minus 60. Right, which is 300 degrees. So it looks like this is going to be equal to 300 degrees. So cosine of 60 is the same as cosine of 300. And sine of 60 is the same as sine of 120. Okay, because we want the sign, SIGN, to be correct, right? So in the first quadrant, at 60 degrees, they were both positive. So I need to find the other quadrant where sine is positive. That was the second quadrant. I need to find the other quadrant where cosine was positive. That was the fourth quadrant. Okay. Sometimes, I mean, you can see me. You have to think about this a little bit, right? Sometimes you have to draw pictures and really think about it. All right. One last thing, and that'll be it for this section. So at the very beginning, I talked about a circle of radius r, and then we kind of simplified it to radius 1, like the unit circle. Let's go back to the circle of radius r for a minute. So if I have a circle, and now we're going to say that the radius is r. So this is r. So this would be the angle theta, right? And then this point right here would be xy. So we know in general, let me draw this a little neater here. In general, by definition, the sine of the angle theta is equal to y over r. And the cosine of the angle theta is equal to x over r. Well, therefore, if we just rearrange these formulas, we could solve for the x and the y, right? Because often you will want to find the x and the y. So if I multiply in the first case, right, if I multiply both sides by r, these cancel, and I have that y is going to equal r sine theta. Remember, with the unit circle, r was 1, so y equaled sine theta, right, which we had before. And then same thing for the other formula. I have cosine is equal to x over r. So if I multiply both sides by r, r's cancel here. I'm going to get x is equal to r cosine of theta. Okay, so these are often useful. These are like the coordinates, the x and y coordinates, based on the radius and the angle theta. So one last problem here. Let's say you're asked to find the coordinates of a point on a circle with radius 5, so r equals 5, corresponding to an angle of 15 degrees. Okay, so let's draw this out, right? So I have, here's my circle, the radius is 5, and I want to find the coordinates, right? The x and y coordinates. Well, we know that and this is 15 degrees, right? So this angle is 15 degrees. we know that the x-coordinate is equal to r times cosine of theta. So the x-coordinate is going to equal 5 times cosine of 15 degrees. Okay, 15 degrees is not a special angle. So for this, you're going to have to approximate this by plugging into your calculator. Make sure, this is important, make sure that your calculator is in degree mode, right? When you're measuring your angle in degrees. In radian mode if you're measuring angles in radians, but in this case, we're going to use degrees. So make sure your calculator is in degree mode. And you should try this and you should get 4.8. So the x-coordinate is 4.8. And in the y-coordinate, well, we know in general that y is equal to r times sine theta. So in this case, y is going to be 5 times sine of 15 degrees. If you plug that into your calculator, you're going to find this is equal to 1.3. So that's 1.3. So that point on the circle right there has coordinates 4.8, 1.3, right? Because those are the xy coordinates. And we found x by using r cosine theta. We found y by using r sine theta. All right, great. So that's it for 7.3. The next section, 7.4, we're going to talk about the other trigonometric functions. So the ones that we haven't talked about yet, tangent, cosecant, secant, and cotangent. And it turns out, actually, they're all related to sine and cosine. So if you understand the sine and cosine stuff well, then you're going to have no problem with the other trigonometric functions. Great. Thank you.